Answers to assignment questions. Question 117. In the experiment of mixing, we have to do the mixing very quickly in order to reduce heat loss to the surroundings. Otherwise, the final temperature will be lower than expected. Question 119 is a simple question on mixing. We have hot water at 80 degrees Celsius, also cold water at 20 degrees Celsius, mixing together in a foam cup, which does not absorb or release heat. So the hot water will release heat during mixing with a temperature drop of 80 minus X. The energy absorbed by the cold water will be given by this expression, with a temperature rise of X over 20. And so X, which is the unknown final temperature, will be 62.9 degrees Celsius. Question 120. In this case, we have a piece of hot metal, 90 degrees Celsius of copper, and water at 20 degrees Celsius, also mixed together in a foam cup. The energy released by the hot copper will be totally absorbed by the cold water if there is no heat loss to the surroundings. So the final unknown temperature will be 20.5 degrees Celsius. Question 121. In this case, a hot piece of steel block is put into water, and the temperature of this steel block changes from 100 degrees Celsius to 23 degrees Celsius. We can easily find the energy released by the hot steel block, and that energy released should be absorbed by the cold water, originally at 20 degrees Celsius and finally at 23 degrees Celsius, with a temperature change of 3 degrees Celsius. In that case, we may find the mass of water, m. Question 122. This becomes a more challenging question, as there is a container, and this container has a heat capacity. So this container is not made of foam, but it must be some kind of other materials that absorbs heat and release heat easily when temperature change. And that container contains hot water at 60 degrees Celsius originally. When 2 kilograms of cold water is added, then the container also has a temperature drop. So there are two hot objects, one is hot water and other is hot container. Both of them release energy when they are mixed with cold water. The hot water releases that amount of energy, while the hot container releases this. Altogether, it will be absorbed by the cold water. Make sure you know X is larger than 20 and X is smaller than 60. And that's how we may write the energy released and energy absorbed by the different objects here. Then solve the question carefully to find the correct answer for the 3.95 degrees Celsius. Question 123. In the last few questions, we have made an assumption, which is there's no heat loss to the surroundings, so that the heat released by the hot objects will be totally absorbed by the cold objects. Otherwise, the final temperature will be lower. Question 124. In this question, you have a hot aluminum block at 90 degrees Celsius, which is added to 2 kilograms of water at 25 degrees Celsius. So, it's not too difficult for you now to find the final temperature after their mixing, 31.29 degrees Celsius, in which we assume there's no heat loss to the surroundings. Now, if you check their temperature change, you will find that the temperature change of water is only 6.29 degrees Celsius, and the temperature change of the metal block is 58.7 degrees Celsius, so much larger for the aluminum block. So why? The reason is because of the heat capacity. If you look at the equation above, then this represents the heat capacity of water 2 times 4,200 heat capacity of water, and the heat capacity of the aluminium block is 900. The reason why it has a smaller temperature change for water is because of its larger heat capacity.